Let's look at problem number 5. We want to compute the orthonormal vectors q sub 0 and q sub 1 that span the same space as a sub 0 and a sub 1. So there is an algorithm that we must go through. The first thing we usually do is find rho sub 0, 0, which is actually the length of a sub 0. And then what we do to find q sub 0 is we take 1 over rho sub 0, 0 times a sub 0. We just make it of length 1. Next step is to compute rho sub 0, 1, which is found by taking q sub 0 transpose and multiplying that by a sub 1. The next thing we would like to do is to find a sub 1 perp, which is a sub 1 minus rho sub 0, 1 times q naught. After we find a sub 1 perp, we find the length of a sub 1 perp, which we'll call rho sub 1, 1. And finally, q sub 1 is rho sub, or 1 over rho sub 1, 1 times a sub 1 perp. So let's see if we can do that. So first of all, what's the length of a sub 0? This is a sub 0. The length is going to be the square root of the dot product of a sub 0 with itself. So it's the square root of 1 squared plus 1 squared plus 0 squared, which is the square root of 2. Now that means that q sub 0 is 1 over the square root of 2 times 1, 1, 0. Rho sub 0, 1 is this transpose times a sub 1, which is 1 over the square root of 2 times 1, 1, 0 times the vector 1, 0, 2, which is 1 over the square root of 2 times 1 times 1 plus 1 times 0 plus 0 times 2, which is 1. So the result is 1 over the square root of 2. Now, a sub 1 perp is 1, 0, 2 minus 1 over the square root of 2 times q sub 0, which is 1 over the square root of 2 times 1, 1, 0, which means that the a sub 1 perp is 1, 0, 2 minus 1 half, 1 half, 0. 1 minus 1 half is 1 half. 0 minus 1 half is negative 1 half. And 2 minus 0 is 2. Now, the length of a sub 1 perp is, well, it's the square root of the dot product. So it's the square root of 1 half squared plus negative 1 half squared plus 2 squared, which is the square root of 18 fourths, which is 3 square roots of 2, I think, if we simplify it. And so that means that q sub 1 must be a sub 1 perp divided by this, which means that it's the square root of 2 over 3 times 1/2 negative 1/2 2. Okay, now that means we found q sub 0 and q sub 1. In B, what we're supposed to do is to factor A using QR factorization. Well, Q is just the matrix with its columns, Q sub 0, Q sub 1, the bases we just found. So that's just the matrix with columns. Let's see. Q sub 0 was 1 over the square root of 2 times this vector, so it's just the matrix with first column 1 over the square root of 2 times, second entry will be 1 over the square root of 2, and the last entry will be 0. And then Q sub 1 is this vector, so it's going to have entries, the square root of 2 over 6, this square root, or negative the square root of 2 over 6, and 2 square roots of 2 over 3. So I'm sure we could find a nicer form for this matrix, but that's Q. And R is made up of the row values that we found when we were creating our orthonormal basis. And so row sub 0, 0 was the square root of 2. Row sub 0, 1 was 1 over the square root of 2. That's going to be 0. And row sub 1, 1 was 3 over the square root of 2. So that's it.